Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to C1 physics class. In week 6, we will going to start the new chapter forces. So the subtopics of the chapter which will be discussed today are forces, balanced and unbalanced forces, Newton's third law of motion. Objectives of the current lecture are, by the end of the lesson, students will be able to state Newton's third law of motion, describe the effect of balanced and unbalanced forces. So we're going to start with the definition of force. Suppose you are outside the room and the door is closed. You want to open the door. You will going to do what? You will going to push the door away from you to open the door. Similarly, if you are inside the room and the door is closed and you want to go outside, you will going to pull the door towards you to open the door. So what is force? Basically, this push or pull is the force. Force is a push or pull that one object exerts on another object. So whenever two bodies they interact with each other, they exert force on each other, and they exert force in the form of push or pull. Now, what are the effects of forces? Forces, they produce motion or they tend to produce motion. They stop or tend to stop the motion of an object. So basically, they change the state of an object. There are two possible states for an object. Either the object is in the state of rest or it is in motion. So if we want to change the state, force is required. Force, it has a direction, so force is a vector quantity. SI unit used for the measurement of force is Newton. So what is force? Force is a push or pull that one object exerts on another object. It produces or tends to produce motion. It stops or tends to stop the motion. It is a vector quantity, and SI unit used for the measurement of force is Newton. Next, we have to discuss the types of forces. The first type is the contact force. Whenever two objects they are in contact with each other, then the force exerted, that will be the contact force. For example, if you are holding a pencil, so the force present between the finger and the pencil is the contact force, because the finger is in contact, it is touching the pencil. So how to define a contact force? The push experienced when two objects press together. Next is the weight. Other name for weight is force of gravity. It is the gravitational pull of the earth on an object. Weight is a vector quantity, so it has a direction. Direction of weight is always shown by drawing a downward arrow from the center point of the object. The arrow is drawn in the downward direction from the center point of the object. This downward arrow shows the weight of this apple, which is acting vertically downward. Next is the friction. Friction is the opposing force. It slows down the motion of an object. So if the body is moving towards right, friction will going to act in the opposite direction, that is towards left. Next is the tension. The pull at both the end of a stretch spring or a string or a rope is said to be tension. For example, over here, the person is pulling this box in the upward direction. So the weight of this box is acting in the downward direction. The tension will going to act along the rope in the upward direction. Over here, a box is being moved towards right with the help of a string. So the forward force, the pulling force applied by the hand is acting it is acting towards right. It is acting in the forward direction. Tension will going to act on the string in the backward direction. Similarly, over here, this is a bucket of water. The weight of the bucket is acting in the downward direction, and this bucket is being pulled up by the means of the rope. The force acting on the rope, that is the tension, it is shown by an upward arrow. So it acts in the opposite direction to the weight. For vertical motion, weight and tension, they are acting in opposite direction. Next is friction. Resistance, basically the resistance. So resistance is the friction in case of fluids. Fluids can be oil or air, right? That is the example. Over here, the parachutist is falling vertically downward with constant speed. So one is the force, weight, which is acting in the downward. Other is the force exerted by the air molecules on the parachute in the upward direction. And that force is said to be the air resistance. Similarly, if a car is moving on the road, so the friction, that is the air resistance, will be shown in the backward direction. If the car is moving in the forward direction towards the right, resistance will be shown in the backward direction. Over here, the person is swimming in water. So the thrust is the force applied by the person on the water. The drag is another name for the resistance. It is the force applied by the water molecules in the opposite direction. So it will be in backward direction. Thrust over here is acting towards left. Drag will going to act towards right. The next is electric forces. It is the push or pull between the electric charges. Push or pull will be in the form of attraction or repulsion. For example, if we have two oppositely charged bodies, one is suppose proton, other is electron. Proton, it has positive charge, electron, it has negative charge. So they will going to attract each other, they move towards each other. Similarly, if we have two bodies having similar charge, then it is observed that they repel each other. Repel means they move away from each other. So this force of attraction and repulsion is basically the electric force. Next is magnetic force, the push or pull between magnets, or the attraction of magnets and magnetic material, that is said to be the magnetic force. In these two diagrams, we can see that there is a magnetic force in the form of force of attraction between the magnetic material and the magnet. Over here, the magnetic material is the paper clips and they are attracted to the magnet. Over here, we have thin slices, thin chips of iron, and since the iron is a magnetic material, it is being attracted by the magnet. The third diagram shows the attraction and repulsion between magnets. Over here, two unlike poles are facing each other, so they move towards each other due to attraction. Over here, two like poles, S pole, they are similar poles, they are facing each other, so they will going to repel each other, they will going to move away from each other. Over here, the north pole of the two magnets is facing each other, so similar poles, they again repel. So when they repel, they move away from each other. Next is the recap of types of forces. Forces are what they are, basically push or pull, which one object exert on another object. So the first type is the contact force. The push experience when two objects press together is the contact force. The gravitational pull of the earth or the force of gravity is known as weight. Friction, it is an opposing force. It slows down a moving object. Tension, the pull at both the end of the stretched string or rope is tension. Friction is given a new name, resistance, in case of fluids, in case of oil or air. So what is resistance? It is the opposing force in fluids such as oil or air. Electric force is the push or pull between electric charges. Magnetic force is the pull or push between the magnets only or the magnets on magnetic materials. Next, we have to discuss Newton's third law of motion. Now, what is the statement of this law? According to this law, whenever two bodies they interact with each other, they exert force on each other. And those forces which are being exerted over one another, they are said to be action and reaction. So for every action, there is an equal and opposite reaction. Example of Newton's third law of motion. We're going to start with the first example, and that is a book lying on a table. So over here, a book is lying on the table. What is the action and what is the reaction in this case? Action and reaction both are forces. Action is the force exerted by the books due to its weight in the downward direction, weight of the books acting the downward direction. And reaction is the force exerted by the table on the book in the upward direction. So these action and reaction, they have equal magnitude, but their direction is opposite according to Newton's third law of motion. Next example is the flight of rocket. When the fuel of the rocket is burned, hot gases rush out with great speed from the tail of the rocket. That is the action. What is the reaction? Due to the reaction of these gases, the rockets they move forward in the upward direction. The next example, when we walk, actually we are doing what? We are applying force on the ground by our feet in the backward direction. That is the action. Now what will be the reaction? The ground will going to exert a force on our feet in the forward direction, due to which we are able to move in the forward direction. Next example is while swimming, what happened? The person apply a force by the feet on the water in backward direction. That is the action. Now, what is the reaction? Now, in return, the water will going to exert a force on the person in the forward direction. In the last, we will going to do the recap of Newton's third law of motion. So what is the statement of this law? For every action, there is an equal and opposite reaction. This law tells us about the four characteristics of forces. Forces always occur in pair. If there is an action, there will be an equal and opposite reaction. Each pair is made up of action force and a reaction force. Action and reaction forces, they are equal in magnitude. Action and reaction force, they act in opposite direction. Action and reaction force, they act on different bodies. Next, we're going to discuss balance forces. Before discussing balance forces, we're going to discuss what do you mean by a resultant force. When an object has several forces acting on it, the effect of a force is the same as the one force acting on the object in a certain direction. And this overall force is called resultant force. In simple words, if more than one force is acting on a body, a number of forces are acting on the body, and when you add them, you get a single answer. That single answer is the resultant force. Balance forces. If the resultant force acting on the body is zero, then the forces acting on the body, they are said to be balanced. If resultant force is acting on the body, it does not change the state of the body. There are two possible states of an object. Either the object is in the state of rest or it is moving with uniform speed. So if balance forces are acting on a body at rest, it remains stationary. And if balance forces are acting on a body moving with constant speed in one line, it keeps on moving with constant speed in one line under the action of balance forces. These are the examples of balance forces. A book is in the state of rest on a table. Over here, two forces are acting. One is the weight of the book acting in the downward direction on the table. That is the action. Other is the reaction force. That is the force exerted by the table on the book in the upward direction. So they are balanced because their magnitude is same and they are acting in opposite direction. Over here, a person is standing on the ground. The weight of the person is acting in the downward direction. That is, the force is being exerted by the person due to its weight on the ground in the downward direction. That is the action. Now, what is the reaction? The ground will going to exert a force on the person in the upward direction. These two forces, they are equal in magnitude and they have opposite direction according to the Newton's third law of motion. Over here, an aeroplane, it is in air and it is moving with constant speed. There are two horizontal forces acting on it. One is the thrust, which is the force applied by the engine of the aeroplane in the forward direction. Other is the drag. Drag is the force exerted by the air molecules on the plane in the backward direction. Drag is basically the air resistance. Other name for air resistance is drag. So these two forces, they are equal in magnitude and opposite in direction according to the Newton's law of motion. So then these forces, they are said to be balanced. In all these three examples, the forces, they are balanced forces because their magnitude is same but their direction is opposite. And when you calculate the resultant force in each case, the answer is 0. Over here, 3 Newton force is acting in the downward direction, 3 Newton force is acting in the upward direction. That is for the example of the book when it is in the state of rest on the table. So the net force will be 0. Similarly, if a person is standing on the ground, 3 Newton is the weight of the person acting in the downward direction, and the reaction force 3 Newton is acting in the upward direction. So net force again over here is 0. Similarly, if the thrust acting is 3 Newton, thrust exerted by the engine of the airplane is 3 Newton, and the air resistance or the drag acting in the backward direction is 3 Newton, again the net force, the resultant force will be 0. Okay, this flow chart shows balance forces. So when balance forces, they are acting on an object at rest, it remain at rest. And if the balance forces are acting on a body moving with constant speed, it keeps on moving with constant speed, it stays in motion. Balance forces, they do not change the state of the body. Similarly, they do not change the velocity of the body. If the body is at rest, the velocity is 0, it remains 0. If the body is moving with constant speed, for example 15 meter per second, no change in the speed under the action of balance forces, it keeps on moving with a speed of 15 meter per second. If balance forces are acting, acceleration is 0. How acceleration is 0? For example, if an object is at rest, then velocity is 0. Formula of acceleration is final velocity minus initial velocity divided by time. So both initial and final velocity, they are 0 if the body is in the state of rest. Acceleration becomes 0. Similarly, for a body moving with constant speed, 15 meter per second, it means that both initial velocity and final velocity, their value is equivalent to 15 meter per second. Formula of acceleration is final velocity minus initial velocity divided by time. So both have same value, 15 minus 15, answer is 0. So under the action of balance forces, there is no change in the state of the body, there is no change in the velocity of the body, and acceleration is 0, resultant force is 0 under the action of balance forces. Next are the examples for unbalanced forces. In the first example, we can see that there are two persons pulling the rope towards each other. The first person pulls the rope towards right with a force of 30 newtons. And the other person, the second person, is pulling the rope towards the left with a force of 50 Newton. So what is the resultant force over here? It is not zero. If the resultant force is not zero, then the forces, they are said to be unbalanced. How to calculate the resultant force? 50 minus 30. One of the force will be given opposite sign. So over here, greater force is given positive and the smaller force is given negative sign. 50 minus 30 becomes 20 Newton. The direction of the resultant force is always in the direction of greater force. Over here, greater force is the 50 Newton and it is acting towards the left side. Therefore, the resultant force, which is the 20 Newton, it will going to act towards the left side. The second example of this bird flying vertically downward. Two forces are acting. One is the weight of the bird acting in the downward direction, which is 25 Newton. Other is the air resistance acting in the upward direction and its value is 60 Newton. Over here you can see that these two forces, they are opposite but they don't have same magnitude. Their magnitude is different. So over here when we calculate the resultant force will not be zero. Resultant force will be equivalent to 25 minus 16. Answer is 9 Newton. Direction of the resultant force is always in the direction of greater force. In the example of bird, the direction of the resultant force will be downward because the direction of the greater force, which is the weight, is downward. Greater force over here is the weight. So direction of the resultant force is also downward. Next example of this trolley moving right over here, two forces each of 4 Newton are acting towards right, and the air resistance, it is acting in the backward direction and its value is 3 Newton. So what is the resultant force over here? 4 plus 4 minus 3. Both these two forces, they will be given positive sign, and the force acting in the opposite direction, that is the air resistance, will be given negative sign. 4 plus 4 minus 3 becomes 5 Newton. Resultant force always act in the direction of greater force. Over here, 4 plus 4 Newton is 8. So 8 Newton is a greater force as compared to the 3 Newton and it is acting towards right. The fourth example of the flight of the rocket. The weight of the rocket is 100 Newton acting in the downward direction, and the air resistance is acting in the upward direction, that is 300 Newton. How to find the resultant force? 300 minus 100, answer is 200 Newton. And the direction of the resultant force will be in the direction of the greater force. Greater force is the 300 Newton acting in the upward direction. Therefore, direction of resultant force is also upward. So what is unbalanced force? Unbalanced forces. If the resultant force is not zero, then the forces acting on an object are said to be unbalanced. Under the action of unbalanced forces, the state of the body changes and acceleration is not zero in case of unbalanced forces. If it is not zero, then the body will be either accelerating or decelerating. Now we have to see the situation when the body is accelerating. There are two possible situations. One is for the vertical motion, other is the horizontal motion. So if an object of an if the weight of an object falling vertically is greater than the air resistance, then it will be accelerating. Accelerating means that the speed will be increasing. Or if the forward thrust of a moving car is greater than the air resistance, then it will be accelerating. Now we have to discuss the situation when the object is decelerating. If the air resistance of an object falling vertically is greater than the weight, then it will be decelerating as speed will be decreasing. Similarly, if the forward thrust of a moving car is smaller than the air resistance, then it will be decelerating. In case of accelerating situation, the upward downward forces over here they will not going to have equal length. Their lengths will be not equal. In deceleration, the direction of air resistance is backward and the direction of the forward force, that is the thrust, is acting in the forward direction towards right. You can see that their magnitude is not same. Their magnitude will not be same. Over here the magnitude is also not same. So if the magnitude of the forces acting on the body is not same, then either the body is accelerating or it is decelerating. In the last, we are going to do the recap of balanced forces and unbalanced forces. If the resultant force acting on the body is zero, then the forces acting on the body, they are said to be balanced. If the resultant force acting on the body is not zero, then the forces acting on the body are said to be unbalanced forces. Under the action of balanced forces, there is no change in the state of the object. Under the action of unbalanced forces, the state of an object changes. Velocity of the object does not change in case of balanced forces, but in case of unbalanced forces, the velocity of the object changes. If velocity is not changing in case of balanced forces, it means acceleration is zero. But in case of unbalanced forces, their velocity is changing. So change in velocity is acceleration. Either the body will be accelerating or it will be decelerating. If the speed of the body is increasing, it will be accelerating. If the speed of the body is decreasing, it will be decelerating. Okay, the recap of Newton's third law of motion. For every action, there is an equal and opposite reaction. It tells us about the four characteristics of the forces. Forces always act in pair. Each pair is made up of action force and a reaction force. Action and reaction, they are equal in magnitude. Action and reaction, they act in opposite direction. Action and reaction forces act on different bodies. This is all. I hope the topic is clear to everyone. So, whenever we interact with each other, we have to show our best behavior. Do not push, do not pull anyone. Allah Hafiz, take care.